Hello, we're ready to start talking about creating our own classes and objects. And this is the last part of chapter 1, or the introduction chapter for the course. Um, we're going to be creating abstract data types in this course, and we've already talked about object-oriented programming and that every piece of data in Python is actually an object and it's based on a class. So object-oriented programming gives you a really powerful way of organizing your code, where you define objects and the objects can interact with each other by, quote, sending messages to each other. And you can usually model objects on real-world entities or entities that you make up that make sense to you. Um, the basic thing that you have to do when you want to work with objects is you start by designing a class. The class is a blueprint in many ways for the object because it defines the data, which is the state, and it defines the methods, which are the actions or the messages that the object will respond to. Now, in the book, we're going to talk about the fraction class as an example first. Fractions are useful to represent as objects. So remember, a fraction is two parts. They're composed of two integers, a numerator and a denominator. The top value is known as the numerator. It can be any integer, and the bottom value is called the denominator, and it can be any integer greater than 0, because of course if you have a 0 on the numerator you have an infinite value. You can create approximations of any fraction using floating point, but to have the absolute exact value, this new fraction class will create objects that will represent that. So you can represent 1/3, and because it stores the 1 and the 3 inside the actual object, it will be very precise in what fraction it's representing. We want to be able to allow fractions to, we want to allow methods that we can call on fractions to do all the things that you would normally do with numbers. So add, subtract, multiply, and divide. So we're going to see how to do that. So first of all, how do you create a class in Python? And we've included a reference in the main week that also goes through the basics of creating classes in Python, which is pretty well written. But if you just wanted to create a class that had nothing in it, you could say class fraction. And then you could say pass. It would actually create a class. Let me demonstrate that. So you say class fraction. So the syntax is you say class, that's a keyword in Python, and then you name your class you're creating, and by convention classes start with an uppercase letter. Then you do a colon, and then you indent all the parts of the class are called the class members. The class members are methods or their data. But we're going to see, we're just going to say pass. So this is actually a legal class. It doesn't have anything inside of it, but we can create objects of it. So I'm going to create an object, and this is how you create an object of that class. You just say fraction. And I'll create another object. So technically what's happening right now is we have created two objects based on this template, and the template creates an object that is where the data type is known as a fraction. So data type is synonymous with the word class when you're doing object-oriented programming. So both O1 and O2 point to an object in memory, which is of type fraction. It has no data and it has no methods, but they are unique. So every object is unique, and you can test, let's print out if O1 is equal to O2. They should be different objects, so that should return false. So go ahead and run that. And you can see it prints out false. So now this isn't really exciting yet, so let's actually add what we want. So we want this fraction class to hold some data. So how do you define the data it holds? And what you do is you define a special method. It's actually called a magic method. There's a whole bunch of methods you can define for classes that start with 2 underscores, like that, and then they have some name that's actually standard, and then 2 underscores. And so that's the name of the method, is underscore underscore init underscore underscore. This is a magic method that automatically will get invoked when we create a new object of this class. And then we're going to do left parentheses, and oh, we have forgot the word def. Let me do that over. So I'm going to say def underscore underscore init underscore underscore. Now you notice it wants to finish what I'm typing. Because it's such a standard method, it's going to help me out. So whenever you have objects, they point to something in memory, and you can create any number of fractions of that object. So how do you refer to the current object in your code? And that's what the word self is about. Every method or magic method you define as part of your class, if it's going to work with the object, a specific object, self refers to the current object that it's going to work with. So when you're first creating the class, you're basically, self is pointing to where the object is in memory, and you have to now define the data for the class, and that's what init is for. Init is called the initialization method for the class. It's also called the constructor, which is the more common term used throughout object-oriented programming. So what we're going to do here is we're going to say self dot numerator, and I'll abbreviate it. We'll set to 1. So we'll give it a default, and we'll say self dot denominator is equal to 2. And this isn't how we're going to end up, so I'm going to just demonstrate a really simple class. So what this does is when I make an object, so I'll call F1, and I'll make a new object by doing this. So this is the standard way you create an object. And so when you say fraction in parentheses, it says create a new object to that. And this automatically calls this magic method once it's allocated the memory area, and then it's going to set up a numerator variable and a denominator variable which will belong to that object. So the object in memory, F1, will end up pointing to it. So once it's pointing to it, we can refer to the data members of that object by saying F1 period and then the name of the member. So that would print out the numerator of F1, and this would print out the denominator of F1. So once you create objects now, I can create 100 of them, 10,000 of them, and I can have them all have different values for numerator and denominator. So you have to invoke F1.numerator. What happens is when you say F1.numerator, it goes into the object, and basically self is what refers to that. And so it returns that value, and then we can print it. So let me run this. And, oops, I didn't define F2. I wanted that to be F1. There we go. So it prints numerator over denominator.